Okay, so in the last video, we talked about how we could use this library called NumPy and import from this text file, get our data by loading that text file, parse out the X and the Y data, and then just print that. Now, of course, we want to make a beautiful plot of this data. So we're going to go to our Python packages. We're going to search for one called Matplotlib. This is a common plotting library. Let's go ahead and click install. Now, of course, remember we could go back here and type in pip install matplotlib. Both of those would work. That's exactly what this is doing in the background. But this is just because I'm using a separate user interface, a separate user account. We have all this different Python versions installed. This helps keep them all in line. So you can see it's finished installing. We have that all installed. So now, of course, we need to import that library. And so we're going to say import matplotlib.pyplot. You can see it's trying to auto-complete my lines for me. Pyplot is just a sub-package of Matplotlib that lets us do very simple plotting things. And it's common to call this PLT. So if we go in here, we have our X and our Y. Now the next thing that we want to do is plot it. So we can do plt.plot and then put in, you can see our X and our Y. And this is basically saying, here's our X data, here's our Y data. Then we need to just simply say plot.show. So again, plot.plot will make the plot, plot.show will show it. So if we right click here, let's run it. You can see over here, this is our, this is glitching out. This is the plot that it's made, right? So you can see we have M over Z, we have intensity. We could, of course, zoom in if we wanted to see a particular region here. So this is a very useful, very powerful library, Matplotlib. And kind of the combination of NumPy and Matplotlib means you can do lots of cool different things. So for example, let's start out by trying to think about, maybe this axis of intensity is not so useful. So maybe we want to normalize that axis. So let's go ahead and close this out. Let's go back here. What does it mean to normalize an axis? Well, it means that we need to basically rescale all the Y values so that the maximum is, say, 100, right? So how do we do that? Well, we need to divide all of our Y values by the maximum Y value, right? I'll say that again. We need to take all of our Y values, all of those intensities, we need to divide it by the maximum intensity. So first what we need to do is get the maximum intensity. So we could say Y max, and this is done with a function called numpy.amax or arraymax. And if we put in Y, we can then print Y max. Now, if we're debugging the software, maybe we don't want to plot it every time. So I'm going to go ahead and put in a little number sign here in front of both of those. When I do that, that just says that's a comment. Ignore that when it comes to running the code. So I'm going to go ahead and run that. You can see here it's found the maximum intensity is about 307,000, right? And that makes sense. That was kind of where that maximum bar was when we made the plot. So now what we need to do is we need to divide every one of those Y values by the maximum intensity. So what we could do is we could loop through. We could create a for loop and loop through all of the Y values. If that sounds crazy and intense, it is, because there's a much simpler way to do it. With NumPy, we can do array operations. So basically, NumPy has this array of floating point values, just meaning decimal values. And that's the Y array, right? What we can do is just say Y equals Y divided by Y max, right? And what that will do is just say, basically take the entire array and divide every point in the array by the maximum, right? So let's go ahead and take out this print command and let's add back in our plots. Let's go ahead and run it. I'm going to bring this over. Sorry, I will work on making this so that it doesn't glitch out so badly in the future. So now you can see instead of 300,000 being our maximum, now 1 is our maximum, right? Which is cool. Looks great, but let's say now instead of 1, we want 100, right? So we were looking at percent rather than like a fraction. What would we do there? All we need to do is now multiply this by 100, right? So now basically we're dividing all the maximum, or all the y values by the max, so that will scale it so that the max is now 1. If we then multiply that by 100, then the max is now 100. So let's rerun that. You can see over here, this is our new figure, and now it's up to 100, right? So, of course, let's make this figure a little bit more beautiful. We can add in, so if we say plot.xlabel, we could say m over z, right? Plot.ylabel, we'll say intensity, and we'll put it in %. Let's go ahead and run that. There we go. So you can see we have intensity and we have m over z now. So this is a nice looking plot. And of course we could do things like plot.savefig, and we could save it as testspectrum.png or something like that. And if we run that, let's go ahead and rerun it. You should see somewhere that it's going to create this testspectrum.png file, and you may want to specify the exact location of that. Oh, here it is. Yeah, I thought it would appear in the same folder. So now we have this testspectrum.png, which it put out. So that's how you do very basic plotting.